Hello everyone, for today's webinar I will be joined by Elise Deveau. My name is Jean Villedieu and today we will talk about using graph technologies for intelligence analysis. So first, a quick introduction regarding Linkurious. Linkurious is a graph visualization startup based in Paris, and our main product, Linguist Enterprise, helps organizations around the world identify and investigate hidden insights in graph data. We have more than 200 customers around the world, including French Ministry of Finances, Cisco, or NASA. Linkurious is trusted by leading organizations to solve today's most complex data problems, including anti-money laundering, intelligence analysis, cybersecurity, or medical research.
So, to understand why and how intelligence analysts can take advantage of graph analysis, let's have a quick look at the state of the field. According to the CIA, intelligence analysis is the application of individual and collective cognitive method to weight data and test hypotheses within a secret sociocultural context. The intelligence community includes intelligence collectors, operators, and analysts. For the US Army, an intelligence analyst is someone who is primarily responsible for the analysis, the processing, and the distribution of strategic and tactical intelligence. In the US alone, we count 20,000 of them, and this includes both analysts who work with information obtained from a single type of source, such as imagery or unclassified information, and analysts who routinely work with information obtained from many sources. In the end, one of their main missions is to reduce uncertainty and to provide warning about potential threat. And to do so, they are often required to understand and monitor dangerous individuals or networks. But as the world was changing in the last decades, analysts start to face a more complex environment. Today, analysts are dealing with multiple threats and a wider range of issues that impact national security. They have to be able to face multiple and sometimes simultaneous security challenges from traditional state actors to transregional network or substate group. Also, the threat shapes have changed. They are dealing with highly connected groups transcending borders and traditional classifications. Individuals from a network can be scattered around the globe and still synchronized. And with more and more data being collected, there has been an increasing difficulty to process, connect, and derive value from it. In the recent years, the collection and storage of capabilities of the intelligence community have improved dramatically. But the ultimate value of all this information still depends on the capabilities of analysts to be able to process and retrieve it. They must consider new information as well as previous analysis. They have to interpret and evaluate evidence, imagine hypotheses, and identify anomalies in those large volume of data. And finally, the intelligence community is a segmented workforce, and this can complicate cross-information investigations. For instance, in the US, there are 16 offices and agencies scattered around the federal government. And these entities differ in missions, so analysts are trained to directly meet a specific agency need. This new environment can really change the technology that has been used until this point in intelligence analysis. It's notably the case of databases that are used to store and retrieve intelligence data. Databases are an important piece of technology for intelligence analysis. If we take relational databases, for instance, that have been widely popular the last decades, they were initially designed to codify paper forms and tabular structure, but not to query and visualize important amount of connected data. With relational databases, it's very difficult to get a full picture of how entities of interest are connected. With their structure, it's complicated to detect connections between entities beyond several hops. And that's because they store highly structured data in tables with predetermined columns of certain types and many rows of the same type of information. So querying connections using foreign keys and joins are compute and memory intensive operations that have an exponential cost. So if one wants to understand the connection between entities to get, for example, an understanding of a network, it's definitely not easy. Also, when using relational databases, you have to define the structure of your data model upfront. So this fixed and strict structure provides safety, but is hard to change afterwards. So changes and updates cannot be handled easily. So why does it matter? Because the analytical tools backed by relational databases make it hard and complex for analysis to investigate networks. As a consequence, if they can't look properly at connections within the data, then obviously there is less understanding of how individuals are connected, and they don't take full advantage of the large volume of data that are collected every day. So finally, without a full understanding of the network, monitoring gets more complicated and some threats can stay undetected. Because of all these limitations, a new approach to identify threats and understand groups had emerged. And it's graph analysis, which is a method for the analysis and representation of complex networks. Basically, your graph is a set of objects called nodes and relationships called edges. Graph databases have emerged to facilitate the storage and querying of large graphs. And those graphs can also be displayed as visual representation to facilitate the reasoning. So there are several advantages to this approach. Because relationships are a first-class citizen here, it's easier to understand how information flow through the entities. It allows to use network and link analysis theories. For instance, the analyst can look up the edges between entities and answer how two individuals are related. Or they can evaluate links that may be identified among various types of objects, such as location, people, or transaction. And it can lead to discover non-obvious relationship between people that, for example, were at the same place and had both contacted a specific phone number. Or, as shown on the right picture, people that are connected but through several intermediate nodes. So a graph approach allows to access and explore from a single point of the network. And on top of that, graph databases easily handle big volume and heterogeneous data can be integrated in a unique graph model. So you can query graphs of billions of nodes and edges with today's technology. So in addition to graph databases that are perfect to store graph data, services like Linkurious are designed to empower analysts for graph analysis. Linkurious Enterprise is an on-premise software built for teams of analysts investigating graph data. They can explore and visualize graph data with an intuitive interface, and visualization considerably reduces the scale and complexity of the analysis. Therefore, it speeds up investigation and gives quick insights to produce, for example, better warning reports. And there are several unique features and for analysts in Linkurious Enterprise. For instance, thanks to the integration of the search engine Elasticsearch, analysts have access to a full text search engine. It provides a single search across all the existing data to save time during investigations. The graph database query language Cypher allows more advanced requests, and analysts can look for specific connection or patterns within the data and apply graph analysis method, and then visually investigate it in Linkurious interface. When dealing with large datasets, we need to find ways to focus the analyst's attention on relevant information. And for that, Linkurious provides a solution to streamline threat detection with an alert dashboard. Intelligence analysts can set up alerts for chosen patterns and combine the power of graph-based analytics with human intelligence to detect and confirm alerts. It works in a near real time, which allows a very efficient monitoring. And they can build robust, secure, and scalable custom graph application very quickly. Also, analysts can collaborate and share visualizations thanks to advanced collaboration feature in Linkurious.
So now let's do a demo. In this demo, we have prepared a small data set, a dummy data set, to showcase how to use Linkurious Enterprise for intelligence analysis. So here is a quick schema which explains the data that we are going to be investigating. So in this schema, we see the different nodes and edges which we will encounter later on. So we have a node type which is country here, and this node represents the country Syria with the property Syria as a name. We have persons, and here we have one person, another one. The persons can have multiple properties, including a last name, a first name, an email, a country, an ID, and a watch list. And finally, we have addresses. Here one address, here another one, and phone numbers. Here a phone number, and here a phone numbers. So these are the types of nodes that we will be encountering. And these nodes are linked by multiple types of relationships, including the as-address relationship here between a person and an address, the has-been-to relationship between a person and a country, or the is-from relationship between a person and a country. Persons can have a as-phone relationship with phone numbers, and phone numbers between them as contacted when one phone number has been used to pass a phone call to another one. So here is a brief summary of the data that we are going to be analyzing right now. And to conduct that analysis, we will be using Linkurious Enterprise. Here is the interface of Linkurious Enterprise. We will be using Linkurious Enterprise to investigate the data that I just showcased you. So here we can see 1 and 2 visualizations that were created in the past. We also have a search bar that we can use to look up nodes and entities of interest. So let's try an example. Let's say I'm interested in Robert Wells. So I can type text and I see the results change as a type. And I can make a small typo. I'm still able to find the node I'm interested in. So we can see Robert here. When I click on Robert, I can see some information on the left panel that are attached to Robert as a person. If I double click, I'm going to be able to start exploring and see, for example, that Robert is connected to an address and to a phone number here. That phone number appears to have 4 relationships with other entities. So we can see that it has been used to contact, for example, this phone number here, this one here, and this one here. As this phone number seems to be connected to 4 other entities as per the little number next to it, I'm going to focus my investigation on it right now. Okay, so you can see that this is quite an active phone number. It has been used to contact this phone number here, this phone number here, and this phone number here. I'm going to select these 3 phone numbers and actually expand them. Okay, and we add more nodes to the screen. Okay, and we can see new information popping up, new persons emerging. Okay, I can zoom out or zoom in. If I want to, I can perhaps select only a subgraph, this subgraph here, and remove everything else. So I'm going to invert my selection and hide everything else to just focus, narrow down, I guess, on this graph right here. If I want to, I can also filter the data. Let's say I just want to keep the phone numbers and I want to remove the persons from the visualization. I'm opening up the design panel here. I'm opening up the categories and I'm going to choose to filter to only retain the persons and phone numbers. To only return, the phone numbers. Up. So I've created a graph, by starting from a very precise point and drilling down in the data. So that's an example of an investigation. But we can also use Linkurious Enterprise to monitor certain patterns. I'm going to go in the alerts part of the interface. We see right now that we have implemented one pattern, which is supposed to detect threats. I'm going to click on Edit, and we can see what is really in that pattern. So we can see that it's a query, a cipher query. And the query basically tries to identify groups of at least 3 persons who have been to Syria and who are also in contact, whether via a shared address or via shared phone communications. So that's what that pattern does, and Linkurious uses it to automatically detect groups of persons based on that patterns. Okay, so let's click on Save here. As an analyst, I can review the matches based on that pattern here. So I click on detecting threats, and I can see 3 matches that have been generated using the alert that we have seen. I'm going to click on the first one, and we can see a subgraph that matches our pattern of persons, of at least 3 persons who have been to Syria and are connected between each other via either phone calls or addresses. I'm going to look up Syria actually. Okay, looking up Syria. I'm adding up Syria, and we can see that we do have 1, 2, and 3 persons who have been to Syria. They are not directly connected, but each one of them is connected with the other via quite a long chain of entities. So Bobby, for example, and Jessica are connected by this chain. Okay. Ruff and Jessica are connected by this chain. Okay, and it's very easy to understand what is going on and to quickly assess the situation. Okay, so what we are potentially looking at here are suspicious terrorists who are not just individual travelers who have been to Syria, but who are also communicating outside of Syria. So potentially they could be people to watch for and to monitor more closely. So we can very quickly narrow down or search or and where to focus the attention of our analysts within a large data set. At this point, I may want perhaps to drill down further in the data. So let's say that I want to learn more about one of the person within the data. Let's say Jessica, for example. Can double click. Okay, Jessica is connected to the United States and an address here. We have here Jody Lewis. Jody Lewis is connected to this phone number. Okay, that phone number is quite active and is connected to four entities. Okay, so we can see all the entities which are connected to that phone number. Okay, and I can, extend each one. Okay, we can see a bit of a small network appearing here. So I'm going to extend actually all of these nodes at once, selecting them and expanding them. It sounds like we have a very dense network in this part of the graph, where everyone is in contact with everyone. So that's definitely something of interest. Could be a family, or could be something different. But it is a closed network where everyone is connected with each other, and that's something that pops up in a very visual manner when we use graph visualization to investigate the data. I may want to zoom out or zoom in on a sub part of the graph like that. It's very easy for me to interact with the data. If I want to, I can slice and dice the data. Let's say I want to remove from my visualization the addresses and the countries to really focus on the persons and phone numbers. I'm going to select them and remove everything else. Okay. I may want to switch from this force-directed layout to perhaps more vertical layout like this. Okay, and we can see some interesting patterns emerging. We have some individuals on the top here, and we have 1 and 2 phone numbers on the bottom, and it seems that the phone numbers here are already in a at the root of the network. And even though we don't know much about these phone numbers, it might be interesting to try to investigate the 2 persons who are attached to this, Alice and George, because they could have a very important role in the network. Okay, going back to the force-directed layout right now. Zooming out, zooming in. At this point, I may want to actually save the visualization to communicate my findings with the team. So I'm going to save the visualization. Okay. I can export the visualization to a number of formats, including Excel, CSV, Gephi, GraphML, JSON, PNG, and SVG. So that means that it's very easy to communicate my findings to my team. I can also actually share the visualization with someone else. So let's say I'm working with John. I'm adding John to the visualization so that he will be able to see it and perhaps drill down further in the data. Okay. Going back now to the dashboard. So what we have seen is that we can both conduct a free investigation by exploring dynamically the data, or we can use the alerts interface to monitor certain patterns and streamline the process of identifying outliers, suspicious behaviors in our data. So that was for a quick demo of Linkurious Enterprise and how it can be applied to intelligence analysis.
So, as we've seen, Linkurious is a great fit for intelligence work. A graph approach allows us to gather into a single network different data sources and connect them together. We can then apply link and network analysis tactic to find hidden insights directly in Linkurious. The additional features are also a perfect tool for analysts to fully take advantage of their data. The alert system, for instance, is a good way to automate threat detection. And each alert can easily be reviewed to assess the risk level or simply gather more information. Linkurious offers to intelligence agents a unique entry point to identify hidden insights in complex connected data. Sharing and collaboration features are also important for efficient communication within the team. So, to sum up on the technology side, Linkurious is an enterprise-ready platform. Our on-premise web application is compatible with the modern OSs and browser. On the database side, we are fully compatible with the best product on the market, such as Neo4j, DataStax Enterprise, Graph, or Titan. We also provide a documented REST API for custom integration. Enterprise security is one of the main concerns at Linkurious. That's why our platform is compatible with numerous external authentication protocols and services. Companies can also manage access rights for their users and specify them on entity type level. An audit trail is also available and provide documentary evidence of the sequences of activities for every user. So thank you for watching this video, and if you have any question, feel free to message us.